we will try to explain or to clarify on live. In case there is a pending question, we will try to clarify or to resolve at the end. Okay. So Andres, all yours. Go ahead, and thank you everyone for staying here today with us, and just enjoy the webinar. Okay. Thank you so much.
Good morning, everyone. We will continue with the CUBIK. Well, just a brief resume of the CUBIK.
Andres, if you can, in order to do it as much clear as we can, try to speak louder and as closer as you can to the microphone. Okay, just for the people with the sound, and so easy for them to listen. Okay.
Do you hear me better now?
Yeah, I think so. Yeah.
Okay. Okay, so we'll continue with the CUBIK. Today we will speak about the thermostat function in the CUBIK. Well, CUBIKs are push buttons with a thermostat embedded. Well, they have the temperature sensor and the thermostat embedded, PI thermostat. We have the CUBIKs with 2 buttons, 4 buttons, 6 buttons, and 8 buttons in 2 different sizes, the square format and the vertical rectangular format. Let me show you in the camera these 2 sizes. This one is the vertical format, and this one is the square format. Come back. Well, CUBIKs have different levels of customization. You can see in the last webinar we explained all this deeply. I will now do just a quick overview. We have the basic one. In the basic one, CUBIKs are only white or black without any logo, any icon on it. Then you have the design level, in which you can select a logo, personalize the icons, the background, everything. And the design level, in the design level, the glass is fixed to the electronic. Then we have the capriccio level, in which you can customize everything, as in the design one, but the glass is fixed to the electronics with magnets, so you can remove the glass and put another one without any problem. To customize all these CUBIKs, we have our app, which you can find in our website. If you go to KNX products, in the touch buttons and thermostat area, you will have the CUBIK configurator. So, well, we explained this tool in our last webinar, but, well, a very fast overview. You have a first step. Well, sorry. You have a first step to choose which CUBIK do you want to design. Then you can select the background. You can enter an image, or you can select a color if you prefer for the background. Put an image. And put a picture, this one for example. Okay. And then you have the possibility to customize the icons, to choose which icons do you want to have in each one of the buttons. And then you can select the size of the icon, the position of the icon, also the horizontal position, the color. You can add text on the icon. You also can choose, well, different fonts for the text and different colors also in the text. So, well, you can customize everything in this front part of the CUBIKs. And finally, the possibility to add a logo for offices, for hotels.
Andres, just a second. If you go back, go to the bottom in the icons part, right now we have included the new option where you can send us new vector icons at the bottom. If you go to the bottom, there is a new form over there. There's a new form where you can send us a vector icon so we can add it to our online tool, and you will have it available to include in all your projects. So in case you need to use one specific icon or design you want to use, feel free to share with us in those formats, SVG or Illustrator or EPS, and we will upload it to the online tool. Okay.
Because for now, well, we have several options for the icons, but maybe you need another one. So for now, you can choose these ones, and if you want, you can send us your own icons. Okay, and finally, the logo. Well, for hotels or offices or this kind of buildings, sometimes you need to add a logo. Well, so you can add a logo, you can move it, you can change the opacity, also you can make it bigger, smaller. Well, so you can play with this tool and make any design that you want. All this tool is explained better in our last webinar. So if you want to see it deeply, you can go to YouTube and you can find the video of that last webinar. Okay, so we will come back to our the webinar, and in the last webinar we have been speaking about the buttons, the LEDs, and the night mode and the cleaning mode. So if you are interested in that part of the CUBIK, you must go to the YouTube video to see more information about it. Today we will focus on the thermostat functions, the humidity sensor, and the dew point protection. So, well, I will go to the EPS, the parameters, and in the parameters, in the general configuration of the CUBIKs, you will find these three functions: the thermostat function, the humidity sensor, and the dew point protection. You must activate that functions to parameterize it and to work with that functions. And then you will have these tabs: thermostat function 1, the humidity, and the dew point. We will start with the thermostat configuration. First of all, you must configure which sensor do you want to use. If you want to use the sensor that is embedded in the CUBIK, or you want to use an external sensor. If you use an external sensor, you must link the external measured temperature to this communication object. If you use the sensor in the CUBIK, it will transmit the measured temperature in this object, in this communication object. Well, you can calibrate that sensor if you find that the temperature is not correct or something. You can calibrate that sensor, the internal sensor, and you can choose when you want to transmit the measured temperature. If you want to transmit it cyclically, well, it's quantity of seconds that you choose, or if you want to transmit it when there is a change greater than this value. You can also have both transmission. I will set it that way. And then we move to temperature control. Hey, first of all, you need to to enable the temperature controller, and then you will have several options to configure the temperature control. We will see all these options one by one, and we will see deeply how each one of them works. We will start with the heating only, okay? Well, in the heating only, let me show you the communication objects of the thermostat. Well, you will have the measured temperature, of course, and the set point. And then if you activate the only heating option, you will have only a heating output, okay? To configure this output, you have three different options. Two steps options. In this option, in the output, you will have a 1 or a 0. You will have a 1 every time the temperature that you want to have in the room, the set point temperature, is greater than the measured temperature. So if, for example, you want to have 23 degrees in the room and the measured temperature is 20 degrees, you will have a 1 here. So you can activate the boiler or, well, the machine that you have to heat the room. It will activate this output that you have connected to, for example, a boiler, and the temperature will start to increase. When the temperature reaches the set point temperature plus this hysteresis, it will stop. So it will send a 0 through this communication object, and it will turn off the boiler. Then the temperature will start to decrease again, and it will send a 1 again when you have the set point temperature minus the hysteresis. Maybe understand it better with this graphic, okay? Take into account only the green line and the orange line. Imagine that we have 26 degrees. We have 26 degrees in the room, the measured temperature, and we want to have 22, okay? Well, now we are not in the heating option, only in the cooling one, but the behavior is the same. It turns on that output. Well, it turns on that output, sends a 1 in that output, and turns on the machine that, in this case, is cooling the room. So the temperature starts to decrease, and when it reaches the set point temperature, it doesn't turn off the machine immediately. It needs to go a bit lower. It needs to pass this hysteresis to turn off the machine. Then the temperature will increase again, and when you pass the set point plus the hysteresis, it will turn on again. And well, this is the behavior again and again, okay? So this is how it works, the two steps output, well, for all heating and cooling, okay? If we put the cooling one, we will have the same cooling. And here, instead of the heating output object, we will have the cooling output object, but the behavior is the same. Then another option in the output, the Pwm control. Okay, this is to control valves, especially valves. When you have valves to control well, different rooms with a valve in each room. Sometimes you need a Pwm control to activate that valve. And then we have the continuous control. In the continuous control, instead of a 1 or a 0, in the communication object, you will have a 1 byte communication object, as you see here. Okay, and this object sends a percentage. The CUBIK, well, the thermostat, to calculate this percentage, use the PI controller. Okay, with the PI controller, the CUBIK is taking into account the set point temperature, the measured temperature, and how the difference between the measured temperature and the set point temperature is increasing or decreasing, the speed of that increasing or decreasing of the difference. So with that calculation, it calculates an output, a percentage output that you can use to, well, especially this output is for fan coils, in which you need to select a speed. Well, we saw how to configure a fan coil in our first webinar in the actuators one. You can go to YouTube and see how to configure a fan coil in an actuator. But for a fan coil, you need a speed. So you don't only need a 1 or a 0. You need to know if you need to activate the output 1 for the speed 1 or the output 3 for the speed 3, or you need the speed. So to calculate this speed, you need a percentage. And that percentage is given by this communication object. Okay? Well, you have different ways to configure the PI thermostat and calculate that percentage. Well, you can choose when you want to send that, with which change do you want to send a new value for that percentage. And then the last option here is the additional cooling. Well, you also have it with the heating. Okay, if you select heating, you will have the additional heating output. This is like an output to, if you have two systems in the house or in the installation, you may have one system to work always and the other one only when the difference between the set point and the measured temperature is greater than this temperature, only to help the main system. So if you have, for example, a fan coil and a boiler, you may have the boiler always working and the fan coil only if the difference between the set point and the measured temperature is greater than, for example, 2 degrees. So the fan coil will start if the difference between those temperatures is greater than 2 degrees, and when when that difference is below this value, the fan coil will be turned off, and the boiler will remain working. So now we will move to see, well, if you only have heating and cooling, it is clear. And you also have the possibility to activate the special modes, okay? The special modes are a KNX standard. I will show you. Okay, are a KNX standard. They have this DPT 20.102 H-bake mode. I will show you here. Okay, this DPT and this communication object, and with that special modes in this heating only or cooling only function, if you activate, for example, the comfort mode, you are sending to the set point 22 degrees, 23 degrees. If you activate the economy mode, you are sending 27. You can, well, you can change the values of the different modes, but you are sending the temperatures as if you activate an scene with that temperature. It's only that. Okay, you have 4 different modes which you can activate from this communication object. Okay, so that's all about the heating. Only that with well, without the special mode, you only change the set point, and with the special mode, you can change the set point also with that mode as if they were scenes. Same for the cooling mode, and then we have other options. The heating cooling switch over. Okay, in this mode, you select the mode here. Let me show you here. Have heating cooling switch over. Okay, so you will have a communication object, this one, to change between heating and cooling. So for example, if you have a fan coil that can work with heating and with cooling, you can select that option and you can choose if you want to have heat or heating or cooling. Okay, how does it work? Well, the change in this option is not automatic. You need to change it through the communication object. So, and when you activate one of the modes, the heating mode, for example, in the cooling output, you will have a 0. It will send a 0 through the opposite output. As you see, you have here the heating output and the cooling output. So if you, through this communication object, activate the heating mode, in the cooling output, you will have a 0, in this case a 0%. If you activate the cooling option, you will have a 0 here in the heating output. Okay, so it will only work with the output of the actual mode, the mode that you have activated. With the special modes, it's the same. The special modes works only as if they were scenes. I mean, if you activate, for example, this communication object, you activate the comfort mode, you will have 23 degrees or 20 degrees if you are in the heating option. So this is all about the heating cooling switchover, but there is other option, the heating cooling simultaneous. In the heating cooling simultaneous, there are 3 different options. Okay, let me show you. In the heating cooling, you have the simultaneous one, and then you have the option to put it with no drifts or by drifts. And by drift, you have 3 different options. So there are 4 options, really 4 options, not 3. Well, with no drift, this mode, you can choose between the heating mode, the cooling mode. In the heating mode, you will only have the output, and in the cooling mode, you will only have the cooling output. But there is another mode that is the auto mode, in which the set point, the output will change between the heating output and the cooling output depending on the set point. It will change automatically. You don't need to change with a button or with the app to change between the heating mode and the cooling mode. It will change automatically between the 2 modes. So if you select a set point that is greater than the measured temperature, it will activate the heating output. And when you select a set point that is below the measured temperature, it will activate the cooling output. well, if you reactivate the node read, you will see that in the communication object, we have the heating mode with the heating status, the cooling mode, and we also have this this special mode, the auto mode, to change automatically between the heating and the cooling. So it will activate both outputs depending on what the set point and the measured temperature is. Okay, so this is with no drift. If we go to by drift option, okay, here we have the value of opposite special mode. Then we have different values of, well, of degrees. This is the value of the drift. And we also have the option to now recalculate the special mode. Well, we will start with the value of the opposite special mode. Okay. So in this option, you select a set point, for example, 22, like in the graphic here, and the system will choose the closest mode of the closest special mode for that value. For example, if we are in cooling mode and we select 22 degrees, we select the set point to 22 degrees. We are in cooling mode, 22 degrees, so the system will take the comfort mode as the actual mode. The system will know that we are working on the comfort mode, okay? So I will better explain it here. Okay, we select 22 degrees, okay? It's our set point now. And as I told you, it takes the comfort mode as our actual mode. If we look to the heating set points, to the opposite mode set points, we see that in the comfort mode, we have 20 degrees, okay? So here, you see that the opposite special mode, the blue line, it's in 20 degrees, okay? So imagine that we are in our house and we have 26 degrees of temperature and we want 22 degrees, okay? We set 22 degrees and the system turns on the output value for the cooling. The temperature starts to decrease, and when it reaches the set point plus the hysteresis, it turns off the machine that we have for cooling. Then it will be, well, turning on and off the machine depending on the temperature. And imagine that here, this blue line that is in the middle, imagine that it's nighttime. From this line to the right part. So the temperature starts to decrease. Without our machine, the temperature starts to decrease. And the measured temperature reaches the value of the opposite mode. Okay, reaches the 20 degrees. So the system will automatically change to the heating mode. It will change to the heating mode and it will change the set point to the set point in the heating mode. So as we are in comfort mode, well, it will select the 20 degrees as our new set point. Okay? So now our new set point is 20 degrees. We are in heating mode, so when the temperature reaches the 20 degrees minus the hysteresis, it will turn on the machine, the heating machine, the boiler, for example. And now it will work with this new set point. So this is how the value of the opposite special mode works. depending on the value of the set point in the opposite special mode. So it has the possibility of change automatically between the cooling mode and the heating mode, depending on that value. I don't know if there are questions about this or if everything is clear.
Well, we have some questions in the chat. One is between Kevin, Sergio, and Rafael. They are trying to agree about if you can use another measured temperature in one thermostat from another temperature sensor, and you can show it or you can use it in your calculations. So maybe we can clarify about this.
Well, maybe at the end of the, I mean, I prefer to explain all the options and then we can move to that.
Okay, I'm noting.
If there are questions about this option, I can explain it again. But if the questions are about another things, I think that it's better to answer the questions at the end.
Yeah. Okay. Go ahead.
So about this value of opposite special mode, there are any questions?
No, okay. I don't think so. No, there's not. There's not.
Okay.
So you can go ahead.
So we can move to the next one. Okay. And in this one, that is select a concrete value for the drift. For example, I don't know, 3 degrees. We will have almost the same behavior, but instead of having the value of the opposite special mode to change between the cooling mode and the heating mode, we have the drift. We have the value that we select here. So if we want, for example, 20 degrees in the room, if we select a drift of 3 degrees, the change between the modes will be 3 degrees. I mean, the drift below that temperature. When we are in heating mode, it will be 3 degrees upper that temperature. So the behavior is the same as in this one, but the values of the values for the change between the cooling and the heating mode are different, are the ones that you select in the drift. Okay? So we'll move to the next one, that is the do not recalculate the special mode. If you select this one, it will work always as well with this behavior. That is the same behavior that we have seen here with the auto mode. Which is the difference between this mode with no drift and this one? That in this one you don't have the option to put only heating or only cooling. It will be always working as in the auto mode. So if you select a set point greater than the measured temperature, it will activate the heating output. And if you select a set point below the measured temperature, it will activate the cooling output. And it will always work this way. And that's all about the different modes that we have to control the temperature. We will now move to do some examples that may clarify your doubts. The first example is this one, that it's very simple because we only need to make an on-off control for a boiler, for example, or for imagine a boiler or a AC machine. So if, for example, we have a boiler, okay, we go to the configuration, we will use the internal temperature sensor. And in the temperature control, as we only have a boiler, we only have heating, we will select only heating. Well, we can enable or disable the, well, I will enable the special mode in this case. And well, the initial set point, or if you want to change the set point through object, or have the controllers always on, and you want to have the possibility of turn off the controller. I want to have that possibility. And what do we need to configure here in the output? As we are controlling a boiler, we only need a 0 or a 1. We don't need a percentage. So with the 2 steps control, it's enough in this case. Well, the hysteresis 0.6, it's okay. And we don't need additional heating output. Set points for heating, these ones are okay. And we move to the communication object. Well, in the previous webinar, I show you how to change the set points with the buttons. And we will focus now on the other part. So here we have the on-off for the controller. When the controller is off, you will always have a 0 in the output. If the controller is off, in the outputs you will always have a 0, so the machines will be always off. So this is to turn on off the controller. This is the status. And here we will have the output to link this output with the relay that activates or deactivates the boiler. So this output must be linked with the boiler. Okay. Then here we have the special status of the special. Okay. So now if the measured temperature, for example, is 20 degrees, and we select a set point greater than that temperature, for example, 22 degrees, and we have the controller on, we will have a 1 here that will activate the relay to activate the boiler. We'll close the relay to activate the boiler. We will have a 1 here. When the measured temperature reaches the set point value plus the hysteresis, the output will send a 0. So the boiler will be turned off. Then the measured temperature will start to decrease again. And when we have the set point temperature minus the hysteresis, it will turn on again the heating output. It will send a 1 through this communication object. So the boiler will be turned on. So that's the way to configure, well, to control a boiler. You can do the same with a cooling machine, for example, an AC machine. If instead of a boiler, you have an AC machine and you want it for cooling, you can configure it as cooling only. Okay. In cooling, you will also need only 2 steps to turn on or off the AC machine, and in this cooling output, you must link the AC machine. So now the behavior will be the same, but with the cooling function. So if the set point temperature is below the measured temperature, it will turn on the machine, so it will send a 1 through this communication object and turn on the machine. When the measured temperature reaches the set point temperature minus the hysteresis, it will send a 0 through this communication object to turn off the AC machine. And then again, the temperature will increase, and when the measured temperature reaches the set point temperature plus the hysteresis, it will send again a 1 through this object, turning on the AC machine. If we send through the special modes, if we write about, well, for example, that we want the comfort mode, the set point will automatically be 23 degrees. So if we activate one of these modes, the temperature, the set point temperature, will be the temperature that we configure here. So that's all about this example. And then we will move to the other example that is a bit more complicated, because we need to make the fan coil control for heating and also for cooling. Okay, so in this case, we will have a valve for the heating and another valve for the cooling. And then we will have the fan. So we will need to open or close the valves depending if we have the, well, if we need to heat the room or we need to cool the room. And we also need to give a speed to the fan coil. So for this example, I will add an actuator and also another CUBIK. Okay, so well, we have spoken about the actuators in our first webinar. So if you go to the YouTube video of the first webinar, you will find information about the actuators. But for now, we will configure a fan coil and 2 valves in our actuator. Okay, fan coil and 2 valves, and I will disable the other outputs. So that's what we have in the system: a fan coil and 2 valves. One is the valve for heating, and the other one is for cooling. So, for example, this one is the heating valve. Status. This one will be the cooling valve. Okay. Well, here we have the control for the fan coil. So let's move to the CUBIK. We need to activate the thermostat function and the temperature controller. Now we have heating and we have cooling. So we need to choose between the heating cooling switchover, the simultaneous. Also we need to set one of that behavior modes that I have shown you. For now, I will use this one, the switchover one.
Well, I don't know if it's only me who has the screen frozen or it's all of you. Let's see if Andres is having any problem with the. Okay, it seems that it's frozen for all of you. So let's wait for some seconds to see if Andres is having some problems, and let's try to continue in a while.
I configure here in an actuator a fan coil and a valve for heating and another valve for cooling. Okay, so when we need to heat the room, we will need to activate the heating valve and well, give a speed to the fan coil. And well, the opposite for the cooling mode, we need to activate the cooling valve and also give a speed for the fan coil. So in the CUBIK, if we go to the parameters, we activate the thermostat configuration, and in the temperature control, we need to choose heating and cooling mode. I mean, a mode that with the possibility for heating and cooling. For example, I will choose this one. Remember that in this one, I need to change manually in the heating cooling switchover. I need to change manually between heating and cooling through this object, okay? Then well, I will activate the special modes to send temperatures with the modes, and I will also I want the possibility to turn off the controller if I want. For the outputs, I will need continuous outputs because we want to control a fan coil, and for a fan coil, we need to give a percentage to the fan coil to allow the actuator, in this case, select the corresponding speed. So for heating and for cooling, I need the continuous output, which means the 1 byte output with the percentage. Okay. So now to control the thermostat, what will we need to link? We will need to link the on-off of the thermostat controller, I mean. This is the status of the thermostat. Okay, so when we send a 0 through this communication object, we will have a 0 in the heating output and also in the cooling output. So the fan coil and the valves will be deactivated and we will not have heating or cooling. Then we need to change between heating and cooling manually because we select this mode, the switchover mode, so we need to change manually. So we need to link this communication object. We change the mode from heating to cooling in this communication object, and it will transmit the status of the mode through this communication object. Okay. Then we have the outputs, the heating output and the cooling output, 1 byte outputs. So this is the heating output. And this is the cooling output. And then we have the modes to, well, to give different temperatures with the modes. So special modes. So in this one, we activate the modes, and in this one, it informs us about the actual mode. Gives us the status. Okay, so that's all in the thermostat. But now, well, we have seen the actuators in the first webinar. You can go to the YouTube video if you need more information. But in the actuators, with an actuator with 3 outputs of the actuator, you can control a fan coil. What do you need to control a fan coil? You need to give the fan coil a percentage. So you need to give that percentage through this communication object, the fan speed control. Depending on this percentage and the parameters in the actuators, it will select the speed. It will close the relay 1, the relay 2, or the relay 3 to give speed 1, 2, or 3 to the fan coil. Okay, so here we need to link the outputs of the fan coil. But as you see here, we have 2 different outputs to link in the same communication object. And when you select the cooling mode, it will send a zeros through the heating output. And when you select the heating mode, it will send a 0 through the cooling output. So you need to have always a value different from 0. I mean, if you have in the cooling output at 20%, for example, and in the heating output, as the cooling output is activated, you have a 0. If you link directly both outputs to the communication object of the fan speed control, as it will receive 20% and it will receive 0%. So if it receives the 0%, it will turn off the fan coil. So we cannot do it directly. We need to use a logic gate. So if in the general configuration of the CUBIK, you have the advanced functions in which you can activate logs to configure logical gates. So in this case, we will choose an OR gate with 2 inputs. We need 1 byte inputs, okay, with a percentage. And we also want that the output will be a percentage. So now we can link the cooling output and the heating output in the input, and in the output we can link the speed, which is here. Okay, so now if we have a 0 in the cooling output, for example, because we are in heating mode, but we have a 30% in the heating output, we will have a 30% in the fan speed control. It will always take the percentage that is different to 0. One of these inputs will be always 0, and the other one will be a value. It could also be 0, but normally it will be, I don't know, well, any percentage. So it will take the percentage in the output to send it to this communication object. Okay, and now we need to activate the corresponding valve depending on if we need to heat the room or cool the room. So we will configure another 2 logical gates, and we will make a comparison. So if the input is greater than 0, we will use a constant value that it's a percentage and it's 0%. And in the other one, we will use a percentage that will be given by a communication object. And in the output, we will use only a 0 or a 1 to control the valves. So now, in the input one, we will always have a 0%. So if in the input 2, the value is greater than 0%, the output will be 1. If the value is 0%, the output will be 0. So we need the same for this one. Greater, we need a constant value in the input 1, percentage, 0%, and in the input 2 a communication object, but with also we need also DPT5 to send a percentage, and to receive in this case a percentage, and in the output we need 1 bit. So it's the same in both gates. We go to the communication object, and the output will be to control the valves, the heating and the cooling valve. And in the input, we need to enter the heating and the cooling output. So now, if the heating output is greater than 0%, we will have a 1 in this output. So as we are going to link this output with the heating valve, when the heating output is greater than 0%, we will have a 1 here, so we will activate the heating valve. And the same for the cooling valve. So if the cooling output is greater than 0%, we will have a 1 in the cooling valve. So it will be activated. If we have a 0, it will be deactivated. So if we are, for example, in cooling mode, and it is, well, 20% the cooling output, the cooling valve will be activated. And in the heating output, we will have a 0. So the heating valve will be deactivated. If then we change the mode through this object to heating, the cooling output will be 0%. So here we will have a 0% and the cooling valve will be deactivated. And in the heating outputs, well, depending on the calculations, but we will have a percentage different from 0%, for example, 10%. And as 10% is greater than 0%, the heating valve will be activated. We will have a 1 here and the heating valve will be activated. So this is the configuration for our example. I don't know if now there are any doubts on the chat or.
Yes. Well, we have the seminar have been really intense in parallel with your explanation, also in the chat. So we have many questions, and Sergio has been taking notes about all the questions they have over there. So maybe it's better if we go ahead activating the microphones for the people so they can explain us their question, and then between also Sergio has microphones, so between you and Sergio, I think that you can explain very clear to the people also showing in the interface. Okay. So right now you're activated. Sergio is also activated, and I think the first question can be for Keita from Japan. So Keita, let me activate your microphone, and you can answer all of us. By the way, we are out of time, so I can understand that some people need to leave the presentation. We are not in a hurry, so we will stay here as much time as is necessary. So feel free to keep here with us, all you that want to keep connected with us. And first of all, I'm gonna activate the Keita microphone. Then it's gonna be time for Rafael from Romania to share also with us his impressions, and then Sergio and Andres are gonna answer in detail. So yeah, Keita, I think that right now you're activated, so you can go ahead with your question.
Hello, can you hear me?
Yes, yes, we can.
Yeah, hello, this is Keita from Japan. My question is that in my country, in the residence, we don't use a central HVAC system using a fan coil unit or something like that. For the air conditioning, we use a split unit, a domestic unit. I don't know the right word in the Spain, but in this case, yeah, we don't need a thermostat function, but I would like to have a push button with a monitor to change the set point temperature. In this case, I would like to use a kind of KNX thermostat to send the set point temperature or mode or on-off command to our interface to the split unit. For example, your BS have a split unit gateway to Daikin, Mitsubishi, and so on. However, the thermostat is made for the thermostat, of course. So there is no mode for data point type 20.005.
Okay, let me show you with, well, I need to download the, well, with the gateway, with the climate gateways, like the Daikin gateway that you mentioned, you can send also the set points to the machines, to the split machines. So
Yeah, set point is fine, but how about mode?
In some also in the with that gateways, you can change the modes in the machines. So you can, for example, if you want to change the modes with one of the CUBIKs, you can send. Well, I will download the one of the gateways and I will show you better gateways. For example, the Daikin one that you mentioned. Okay, open that example. Open this example and I will show you. Okay, so if you go to one of these gateways, for example, this one is for Daikin and Mitsubishi, this catalog. Okay, you will find that here you have different modes, okay? So you can send, it's a 1 byte, it's DPT of 1 byte, I don't know exactly the DPT. But you can send with a CUBIK. If we enter here a CUBIK, okay, you have the CUBIK, and for example, we want to change the mode with the button 1. Okay, we want to activate one of the modes with the button 1. So if you go to the button 1 and you send a value, a 1 byte value, okay, well, depending on the mode that you want to activate, you will need to send one value or other value. And you link that value with this communication object that changes between the modes of the AC machine, in this case, the Daikin AC machine.
Andres?
Yeah.
It is function, is the CUBIK thermostat also have this kind of function to send the value from specific pattern?
Yeah, this is a CUBIK. I mean, not in the thermostat, but with the buttons, you can select the mode in the split unit. Okay, this is a CUBIK.
But there's no monitor to change the, to see the set point temperature.
Well, you also have, well, this is for the mode, but for the set point, you can, well, let me activate the thermostat, okay? If you have the thermostat enabled, you can change the set point here, okay? And you can link the status of the set point with this set point temperature, okay? So if you link the status, yeah.
I think you are setting with a 2 push button model. How about the thermostat?
Well, it's the same, it's the same. All the CUBIKs have the thermostat, and let me show you. I mean, you can change with this one, with the TL, and you have the same communication objects, okay? You will have more buttons, and you will have the display with the LEDs to show the temperature, but it's the same. In the 2 buttons one, and in the TL with the display in the upper part, you have the possibility of configure the buttons to send a value. Okay, so it doesn't matter if it's a 2 buttons CUBIK or if it's a CUBIK TL, or all the CUBIKs have this possibility of send values. Okay, so now if we go to...
Okay, I understand.
Okay.
I had a misunderstanding about the thermostat. Yeah, some thermostat from other manufacturers fix the function of the button, but your products can change the function.
Yeah, you can change all the functions of the buttons. You can change the telegrams that the buttons send. So depending on the telegram that you select, you can control different things. So with a button, you can send many different telegrams. We have all this explanation. We have it. You have it in the last webinar, in the YouTube video. So maybe you can take a look to that video, because in that video we explain which possibilities do you have in each button. Okay. You also can activate the scenes. Send always a 1, send always a 0. So in each button, you have all these possibilities to send different telegrams.
Okay, once we have clarified Kate a question, I think we can go ahead with Rafael Marculescu from Romania. He wanted to share he has been also really active in the chat. So maybe he has something to add. Rafael, you have your microphone open right now, so you can go ahead.
Hello, can you hear me?
Yes, we can.
Hello to everybody, Rafael Marculescu, thank you. It was also a topic regarding the control from the TL thermostat or other thermostat, but the TL we use here in the presentation, regarding to use it for two-step heating. For example, the first heating source to be the underfloor heating, and the second to be a fan coil. The first source, the underfloor heating, it's easy because we'll use the TL thermostat in PI, proportional integral mode thermostat, of the room temperature controller, of the thermostat functionality, and will be an output from 0 to 100%. And we'll use the heating output, normal heating output, to be connected with the valve actuators. In our case, for example, we can use the BES actuators. We'll use the valve functionality and the valve with the Pwm functionality to modulate the actuators of the valve, the driver of the valve. But what about the second heating source? In our case, the fan coil. Everybody have common that we'll use the second stage of the actuators. Also, we'll need the second stage of the actuator also with an PI controller with a command from 0 to 100%. But in practice, I use a workaround. I am using the first stage of the thermostat, of the room temperature controller inside the TL, the first stage, and I connect via a unique group address with the valve actuators for underfloor, but as well with the fan coil. The trick here is that we expect then the fan coil to enter, to start working when the request of the heating to be, let's say, bigger than 50 or 60%. In this case, if you'll use the actuators, the fan coil actuators, Andres, if you hear me, can you please switch to the actuators and to show the fan coil functionalities, and when the screen went, okay, this screen, you can adjust the fan speed one threshold, the second and the third. For example, 40 to 60, 60 to 80, and 80 to 100%. So that means the fan coil will enter when the request of the heating request is increasing and increasing and increasing. And by case to case, I advise you to test and to see how it's working and how much the customer is, you and the customer is satisfied. There are some comments, some other questions. I was clear enough in my explanation.
Yeah. Thank you, Rafael. Thank you.
Yeah, I think so. I think you were, Rafael. Thank you so much for your point of view. Because not only that question that you have clarified right now, Andres has shown on the screen, also from Serjan, there was another topic that you have been discussing a lot about how to solve the situation between the underfloor, fan coil, and everything, that it's linked to this point that you have explained right now. Yes. I don't know if, Serjan, you want to also share with us. I'm going to activate your audio, so in case you want to share some point of view with us, feel free to talk whenever you want.
Do you hear me?
Yes, we can.
Okay, my question was basically this one that Rafael explained, but my suggestion is if it's not too big effort for development, maybe for the second stage would be the best if you have the same options as for the first one. So that for the second stage, you can use two-step, PWM, and continuous. Because in our country, we frequently have underfloor heating plus fan coil for heating. And with it can be done in this workaround that Rafael explained, but then you need a lot of time to check for each room and so on how the system is going on. If you are more flexible with the second stage, then it's, in my opinion, much easier to set up system.
Okay, well, thank you so much for the recommendation. I'm sure that Sergio and Andres has taken a good note about your suggestion. As always, we are always open to listen and to know your necessities, so we will consider for sure. Thank you so much. I don't know if there is any other question or someone who wants to talk. If someone has any other question, can text in the well. Right now, I have seen a new question from Keita from Japan in the chat. Andres, if you can check.
Maybe I can speak with Keita directly.
Okay. Okay, that's good. That's good.
Better.
Yeah, because we are a little bit out of time. In case there is any other question, you can write on the. Yeah, Sergio is telling us that there is another question from Abdul Noor about a 0 to 10 volts fan coil question.
Okay, so with the 0 to 10 fan, well, we have 0 to 10 dimmer here. The dimmers. Well, we have this 0 to 10 dimmer, okay? And to control the fan coil directly with a 0 to 10 volt dimmer, you will need to link the output of the CUBIK, the percentage output that we have seen here. Well, I think I delete it now. Well, this one, in this case, heating output, that is a percentage. You will need to link this output with the control of the dimmer. So you can link it directly because in the dimmer you can set a percentage to have from 0 to 10 volts. You can control it with a percentage. So you will be able to control directly with this output. You will control output in the dimmer that will be from 0 to 10 volts. So if you give to this output in the dimmer, I don't know, 70%, for example, you will have 7 volts in the output. So that's the way to control the dimmer. Well, a 0 to 10.
Okay, Andres. Thank you so much for clarifying this point. And we have another good question from Christos. Well, first of all, I'm going to activate Christos' audio so he can ask us directly. Christos from Cyprus, you can go ahead. The question is about the two-pipe system with only one valve. There was a comment from Rafael in the chat about using the logic unit, but Christos, you can go ahead with your question and then we can clarify from our side. So
it was just to show an example about this, nothing else.
Okay, so I will show a quick example about this, okay? So
okay, go ahead.
Let me insert a new actuator and a new CUBIK. Have a CUBIK and we have an actuator, okay? So now we have the same valve for cooling and for heating. That's your question. So, well, I will set, for example, a 9 outputs actuator. Oh, it's okay. And in the output 1, we will connect the valve. Okay, so here we will have the valve. This is to control the valve, and this one is to receive the status. Now, in the CUBIK, we have to control that valve. Well, I will set CUBIK TL. I will turn on, well, let me close this. I will turn on the thermostat functions, the temperature controller, and we have heating and cooling, okay? And in both heating and cooling, we have the 2 steps control because we want to control a valve. So now if we go to the communication object, the thermostat, we will have the heating output and the cooling output, okay? And also the object to change between heating and cooling. So now if we are in heating mode, we will have a, well, and the temperature is, the set point temperature is greater than the measured temperature, we will have a 1 in this output, in the heating output, okay? But if we change to the cooling mode, we will have a 0 here, well, depending on the temperature, but we will have a 1 here. The point is that when we change between the heating mode and the cooling mode, we will have a 0 in the opposite output. So if we are in heating, we will have a 0 in the cooling output. And if we are in cooling, we will have a 0 in the heating output. So if we need to control a valve, we cannot link it directly. We cannot link this directly to the output, to the cooling and the heating output, because if the heating output is activated, the cooling output will be 0. So we will have here a 1 and also a 0 because of the other output. So the valve will be deactivated. So what we need to do here is to set a logical gate. Okay, here, activate one of the blocks. And with an OR gate, each time we have a 1 in one of the inputs, each time the cooling output or the heating output turns to 1, we will have a 1 on the output. So now if we link the heating output and the cooling output to the inputs, when the heating output is 1, we will have a 1 here. And when the cooling output is 1, we will also have a 1 here. And it doesn't matter if the other input is a 0. We will have a 1 each time the heating or the cooling are 0. That's how an OR gate works. So now we can directly link the output with the valve control. Where is it? Valve. So now each time we have a 1 in the heating output or in the cooling output, the valve control will receive a 1, so the valve will be activated. And if both signals, if heating output and cooling output are 0, the valve control will receive a 0 because the result of this gate will be 0. I hope it's clear.
Yes, let me check with Christos. Christos, you have the microphone activated. Is it right now clear for you?
Yeah.
Okay. Perfect. Not sure if there's any other questions. Sergio is answering to Kevin about one question in the chat. In case, is there any other question, you can text on the chat right now. Just to refresh you, next Monday, April 20th, we will have the next webinar about our sensors, movement sensors and lux level sensors. So it's going to be also at the same time, 10 a.m. Spanish time. I will upload to our, you know that we are uploading to our YouTube channel all these webinars. So we are recording the session and we will upload it to YouTube in a while. You have the 2 previous seminars also there online. And as I told you the other day, we are creating our new space in the website to link the presentations, the ETS projects, and even today, I'm gonna save the chat because it has been really interesting, and we will include it also together with the rest of the documentation. So once again, thank you so much for the time you have shared with us today. Has been a pleasure. I think today has been really active and really interesting. Hope it has been useful for all of you. In case you have any question, any pending questions related to temperature control or whatever, feel free to send us an email to the technical department with the email you have on your screen, or also to my email address, export@besknx.com. And hopefully I can see you also next Monday with our next webinar about the sensors. Okay, so thank you so much for the time. Hope you have enjoyed, and let's keep in contact. Thank you so much to all of you. Take care. Bye-bye.